This week is the week of Independence Day, also known as 4th of July. So this week on Animation Summer Camp, it's only going to be a 3-video week. Therefore, each of the videos this week will be one-offs, not connected to any bigger lesson. Back in January, I uploaded a video called the Frame Rate Conversion Formula. Not a lot of people have viewed it, but I don't blame them, because I didn't talk at all in that video, so no one understood what it actually was. So let me write down the formula for you. The first line is based on 24 frames per second standards, or FPS, though any frame rate can be used for this line, but in this case we'll use 24 frames per second. We'll use a 16 frame walk as our action, which will lead us to 3 steps per 2 seconds. We'll then multiply our frame rate by 2, which will also give us 48. We'll then multiply the frame rate we want by 2. Then we'll divide that number by 3. This formula is for retaining timing when converting frame rates. However, in some instances, the division will give us an uneven number. So in one of those instances, just go with the pattern. I'm guessing you're wondering, why would I choose 16 frames per second? To put it quite simply, I heard that the Chaplin shorts were filmed at 16 frames per second. Then when they were played in the theaters, they'd be played at 24 frames per second, making them look faster. About 1.5 times faster to be exact. However, if we end up with an action that can be summed up in 1 second, we just skip straight to dividing the new frame rate by the amount of times the action was done. So, if we're converting 24 FPS to 30 FPS, we'd use 15 frames per step. Or if we're converting 16 frames per second, it'll be 8 frames per step. Now, what if we were to convert 30 frames per second to 24 frames per second? In the following formulas, I'll show you how to convert 30 FPS to 24 FPS while also keeping the timing of your reference. We first want to think about how many frames our action is. We then want to think about how many times our action can be done in a matter of seconds. For 4 frames per action, we get 15 actions per 2 seconds. In that case, we want to multiply 24 by 2 to get 48 frames. Then we divide that by 15 actions to get 3.2 frames per action. However, if the amount of actions culminate to 1 single second, then you can just skip to the division part. For 24 frames per second divided by 6 actions per second, you get 4 frames per action. Well, that's going to do it for this video. I'll see you tomorrow.